Hello everyone, my name is Zhao Han. I'm a doctoral student in the Human-Robot Interaction Lab at UMass Law. Now, I'm going to present our paper, The Need of Verbal Robot Explanations and How People Would Like a Robot to Achieve It. So, what's the motivation behind our work? Explaining our behavior is a natural part of our daily life. Research in psychology shows that the lack of explanations are unsettling and disturbing. So it's important for others to provide explanations to improve understanding. This is especially true for robots, often designed as intelligent beings that resemble humans. Past work in HRI shows that improving understanding of robots makes them more trustworthy and more efficient. However, HRI community has focused on implicit nonverbal behaviors to express robot intent, such as arm movement and eye gaze. The problem of these nonverbal cues is that they do not inform why and what generates the behavior. This stops people from further improving their prediction of the resulting behavior. So they alone may not be enough for a human to fully understand the robot. To the best of our knowledge, relatively little is known about what and how would humans like a robot to explain, like humans do. This is very important and should be done before we empower the robots to explain. To investigate robot explanations, we conducted an online survey on Amazon Mechanical Turk. Our experiment is inspired by human explanation study in the psychology field. Because in order to know what and how people want robots to explain, we want to know what do people want other humans to explain. Research shows that people hope to get causal knowledge. So we control the causal knowledge in our experiments by adding nonverbal cues like head and arm movement to increasingly provide causal knowledge. The study followed 3 by 2 between subjects design. In order to achieve enough statistical power, we have 372 participants, 62 per condition. The sample population is more diverse than the common university population. Their age ranges from 18 to 74. The mean is 37 years old. There are around 200 males and around 150 females. The task in the experiment is a typical handover task. A Baxter robot is asked to hand over a cup. As you can see from the right figure, but the cup is slightly out of reach, which the participants don't know. Let's watch the video shown to participants to establish the handover task context. A Baxter robot was organizing the desk. You were watching Netflix there, and you ask the robot to hand over the cup. What participants don't know is that the cup is slightly out of reach, which is not obvious, as you can see from the video. Here is the 3 by 2 design. Each column represents an execution type, and the rows are for head shakes. The first row is no head shake. The second one is with head shake. The first column is the clueless execution, which is the baseline, where the robot stops organizing and seemed does nothing. You may guess the cup is in the robot's view, and the robot detects the cup, but failed motion planning. Then in the middle column, the opaque condition, where the robot actually turns its head and looks at the cup to give humans some clue. In the third column, we add repeated arm movements to give even more clue. Let's see the results. Specifically, we want to see, as we add more cues, is there a decreasing need for robot explanation? The answer is surprisingly no. We found an equal need for explanations across all conditions, even when we added additional cues like head and arm movement. From the figure, you can see the median values are all on the agree side, either 1 or 2. Here, 1 is moderately agree, 2 is agree. After running factorial ANOVA and the Takis test, we found significant differences across all 6 conditions. We also explored some properties of explanations. Here is the timing aspect. We found that about half participants want the robot to explain its behavior in situ, not in the beginning, which is only preferred by 18% participants. However, for explanations in the end, there is no statistical difference found. People also think engagement is important. Almost 70% of participants said it's important that the robot get their attention before starting to explain its behavior. When asked about how should the robot do it, 37% of participants report that they prefer the robot to look at them before explaining. Only 16% said they want the robot to raise volume. We also asked participants that if robot explanations would be different from human explanations. As you can see, around half participants agreed that there should be no difference in what should the robot or human say. They also don't think there should be any difference in how it is explained. However, more than 30 participants who reported that robot explanations should be different from human explanations, we didn't find any statistical significance. This suggests people don't have a good idea on what the difference would be. Finally, people prefer concise summaries. Most people said yes, only 11% disagreed. When asked about verbosity aspect, how many follow-up questions they would ask afterwards, 74% said they are willing to ask only a few questions, from 1 to 3. Only 16% participants want more than 3 questions. Finally, we coded the comments on what should be explained and grouped them into multiple categories. Here are the top ones. Common to the all conditions, people want to know why it failed to complete the task. This is the number 1 on the list. When there is no arm movement, people would like to know why the robot disobeyed them by shaking its head. When there is arm movement, they found it confusing and want to know why it kept moving its arm, suggesting that the intent of arm movement is not clear to participants. In the clueless execution, where the robot does nothing after it stops organizing, people want to know about its previous behavior, which is kind of interesting. Here are 3 key takeaways. First, robots need to verbally explain. More nonverbal cues does not increase the need for robot explanations, as I mentioned earlier. Secondly, nonverbal cues are not clear, so the head shake is perceived as the robot is not going to do something, rather than is not able to do it. Our movement also rather confuses participants, which is not clear to them. Finally, robot explanations should be provided in time, which is in situ, not in the beginning nor in the end. Explanations should be concise, and people are willing to ask a few follow-up questions. Before starting to explain, the robot should engage people by first looking at them to get their attention. Thank you for your attention. Here is my email, and I also put our lab website there. If you're interested, you can look for other work from our lab. If you have any questions, don't hesitate to email me. I also release the code on GitHub, so it can benefit your research. And you can also reproduce the experiment if you would like. Thank you.